Hello everyone, I am Shravan. I am going to give a presentation about project which is learned during embedded system internship. The project title is Washing Machine Simulation using PIC16F877A. In today's world scenario, household appliances play a vital role in simplifying daily tasks, minimizing physical support, and improving overall productivity. The technological progress, especially the use of the microcontrollers, has transformed washing machines into smart, energy efficient, and easy to use drives. The washing machine project, based on the 60 PIC16 F877A microcontroller, reflects this innovation with the goal of developing a smart, adaptable, and dependable washing machine system. Next, we can go to the what we have learned in the internship. The C and embedded C. The C language is a general purpose high level programming language known for its simplicity, efficiency, and close to hardware control. It is a widely used for developing a system software, operating system, and low level programs due to its speed and the portability. The embedded C is a set of the language extension for C, designed to program microcontrollers and the embedded system. It includes special features like direct access to hardware registers, input and output ports, and the memory locations using specific keywords. Embedded C allows writing efficient, real-time hardware interfacing code control devices like sensors, motors, LEDs, and the more. Next, we can go to the what is an embedded system. The embedded system is a combination of the hardware and the software designed to perform specific tasks efficiently. Embedded systems are focused for control, automation, and performance. Unlike the general purpose computers, the embedded systems are task specific, highly optimized for performance, cost, and size, require no human intervention or very less human intervention. Next, we can go to the categories of the embedded system. The standalone embedded system and the real-time embedded systems and networked embedded systems. In the standalone embedded system, they work themselves and they do not require the host system to run it. And the standalone embedded systems, in this type of the embedded system, which will blindly follow the instruction given by the user. For example, the semi-automatic washing machine are coming under the example of the slave standalone embedded systems. And the independent standalone embedded system, in this type of the embedded system which can take the decision on without simulator interference. Self-driving cars, which are manufactured by Tesla, are the example for this. Real-time embedded systems, in this real-time embedded systems, response time is very critical. For example, air navigation system are coming under the examples of the real-time embedded system. The hard real-time embedded systems, in this type of the embedded system, deadline is very strictly followed. Airbags are coming under the examples of the hard real-time embedded systems. Next, the firm real-time embedded systems. In this type of the embedded systems, property loss when timing is delayed. For example, fire alarm are the example for this. In the soft real-time embedded systems, smart delay is expectable for this type of the embedded system. Next, for example, which is a DVD player and electronic toys are the example for the embedded system which is not time critical. Networked embedded system. In this type of the embedded system, multiple components are connected to perform specific tasks. For example, Bluetooth and home automation are example for the networked embedded system. Next, we can go to the mobile embedded system and the mobile in embedded systems, laptops, phones, and PCs are coming under this mobile embedded systems. And the hybrid embedded systems, many different type of the embedded systems are configured to perform a function of the some application is coming is the type of the embedded systems are hybrid embedded systems. For example, robot are coming under the example of the hybrid embedded systems. Next, we can go through the project. Microcontroller based washing machine simulation using Picsimlab. The project purpose. This project focuses on simulating a washing machine using Picsimlab, aiming to replicate real-world washing machine functionality in a virtual environment. The project begins with a comprehensive understanding of the washing machine components, cycles, and operations. Parameters defining laundry status, such as fabric type, load size, and water level, are identified. The development tools. The MPLAB XIDE and MPLAB XIDE is an integrated development environment from Microchip for developing embedded applications. It supports PIC, AVR, and the SAM and other Microchip microcontrollers. The idea offers features like code editing, debugging, simulation, and device programming. It uses the NetBeans platform, providing a modern, customizable interface. MPLAB X works with the compilers like XC8, XC16, and XC32 for C and the C++ development. In this project, we have used the XC8 compiler. The XC8 compiler. And next we go through further details about the X8 compiler. X8 compiler is a C compiler from Microchip designed for programming 8-bit PIC and AVR microcontrollers. It is a part of the MPLAB XC compiler family, providing support for efficient and optimized embedded code. The X8 offers a different optimization levels, free, standard, and pro. With the pro providing advanced optimization, it fully integrates with MPLAB XIDE, supporting debugging, simulation, and the code generation. We have used the development tools like Picsimlab. The Picsimlab is a graphical simulator for PIC microcontrollers that allows users to test embedded system and circuits virtually. It works with the tools like Pixim and support code written in the assembly or C, including programs compared with the X8 compiler. The Picsimlab provides a real-time interactive environment with virtual components like LEDs, buttons, displays, and sensors, making it ideal for students, hobbyists, and developers to test their code without the need for the physical hardware. If you use the PIC16F877A microcontroller, we, we further discuss the specifications of this microcontroller. 8-bit microcontroller of PIC Genius by Microchip Technology, and you can go to the memory part. And the program memory is 14 KB flash, data memory 368 bytes RAM, and EEPROM 256 bytes. Clock and the power, internal oscillator, low power modes, and voltage typical operates at 5 volt. Development tools, Microchip provides compilers, IDs, and debugging tools. User the several components. Let us go discuss about one by one. Tactile switches in microcontroller. Switches are open, used as inputs to control the operation of the device or to interact with the user. When the button is pressed, the switches turn on. When the button is released, switches turn off. An array of the toggle switches from the digital keypads. Here, in this project, we use the RB3 is used as a switch for navigation between options. RB4 is used as switch 5 powering the washing machine and resume. RB5 used as switch 6 stop and pause the ongoing program. The RB0 is used as switch to indicate the door status of the washing machine. Next, we can go to the CLCD. The CLCD stands for the Character Liquid Crystal Display, commonly used to display characters and symbols in the embedded systems. It typically comes in the configuration like 16 cross 2, 20 cross 4, meaning 16 or 20 characters per line and two or four lines. Okay. The CLCDs are widely used with microcontrollers, display messages, sensor values, or status information. They communicate using either 4-bit or 8-bit data modes, along with control lines like RS, RW, and EN. The CLCDs are preferred for their low cost, simple interface, and ease of integration. And next we can go to the keypads. The keypads are used to give the input by the user in binary format. They consider the push button. They can be triggered in two different ways. Level trigger activated when voltage is on the one high level. Edge trigger activated when level of the voltage is suddenly changed. They cone in two different configurations. Sourcing circuit one on and the zero off. Syncing circuit one off and the zero on. Timers. Next we can go to the timers. Timer is a nothing but a simple binary counter that can be configured to count clock pulses, internal or external. Once it reaches the max value, it will drop back to zero, setting up an overflow flag and generate the interrupt enabled. PIC16F877A has three independent timers which can be used as timer counters for PWM generation. They are timer 0 8-bit timer and the timer 1 16-bit timer and the timer 2 8-bit timer. Next we can go to the interrupts. An interrupt is a communication process which causes the processor to stop its current and the handling interrupt sources. External are the internal sources. Interrupt service routine is a software routine that hardware invokes in response to an interrupt. ISR examines an interrupt and determines how to handle it, executes and returns the logical interrupt value. The PIC has only interrupt service routine. The buzzer. Buzzer in the washing machine is used to keep in track of the washing cycle. It activates for the 2 seconds when the washing is completed successfully. The fan. The fan in the project is used to represent the working of the washing machine. The spin of the motor starts when any washing mode is selected and continues till the end of the washing cycle. The motor stops when it detects door is open and starts again when the door is closed. Next, we can go through the block diagram of the project. To use this block diagram, in the right part, we have used the order component, display, buzzer, and fan. We will explain the functions of these order components in the previous lectures. Next, in the left part, the switch you have shown the switch user. Switch 5 for the power on, which is the RP4. Pause or stop switch 6, which is the RB5, and the door status switch is the one. There is the RB0. Next we can go next we can go through the demonstrate the project. First we have to turn on the Picsimlab and we have to load the hex file. Hex file is created in the MPLAB XIDE. Um, we have written the code related to project in MPLAB XID. We written the header file, source files for the digital keypad, timers, and the CLCD and the main.c. We have all written in the MPLAB. And after building the all the files, we have created a hex files are created, and that hex file we have to dump in the or load in the uh, this for this microcontroller. We use the sitting pros for LCD display. The switch 4, the switch 5, which is the RB4 for the powering on the washing machine, and the switch 6, which is the RB5 to start the function, and the RB4 to store to show the door status, and the RB3 uh, which is used for the option selection and the option navigation. First, if you press switch 5, powering on the washing machine. Uh, this is RB3 is for the option navigation, heavy, delicates, whites, paints, eco cottons, woolens, bedsheet, rinse dry, dry only, wash only, aqua store, daily. When you switch file, the option is select. The water level auto. Here there are five options: low, medium, high, max, auto. Next option will repeat. Um, when you press the long the option is select, and the switch 5 for the start and the switch 6 for the stop. When you press the switch 5 to start and out from daily function wash, and the switch 6 for the pause. When you press the switch 6 stop, fan stops. And again when you press the switch 5, the film starts. The switch 1, which is the RV4, is to show the door status. And next the washed will change to rinse, and the rinse will change to spin. From computer remove clock. And next we will go to the first step. Next, we have successfully demonstrated the project. I will need to go to the conclusion part. And this project also demonstrated the design and simulation of a washing machine using a PIC16F877A microcontroller. The key embedded systems principles are applied to control real-time processes in timers and interrupts. Interface hardware peripherals like keypad, CLCD, buzzer, and fan. Provide a user-friendly interface with mode selection, water level, compression, process feedback. In this internship, we have learned the basics of the embedded system and basic project like washing machine. User, if you, we will explore this into a real world scenario by trying to gain a knowledge about the embedded system deeply, and we implement this in the real world scenario. Thank you.